Now we'll consider a problem on decimation and interpolation, what we have learned in the last part of your theory class, decimation and theory and interpolation theory. So consider signal x of n, which is nothing but u of n. Obtained a signal with a decimation factor of 3. This is one part of a question. And obtained a signal with the interpolation factor by a 3. So we know the decimation is nothing but downsampling the signal at a rate of 3 along with an anti-aliasing filters, which is used to refer to a name called decimator. Similarly, the interpolation is nothing but the process of increasing the sampling rate by a factor of I, and here the factor of I is given as 3. And the given input signal x of n, they have never given the sequence, but then they have given the x of n is nothing but unit function u of n. So first we should know what is the unit function. So the unit step functions is defined as u of n is nothing but 1 for n is greater than 0 and 0 otherwise. And this is a common well-known factor for the unit step sequence. And the corresponding graphical representation, if you see for this u of n, which is plotted here. So you will be having the n samples which are having a level as 1. Now the question comes, we know what is the given signal x of n. We obtained the given sequence x of n now there in the previous slide. And now we need to obtain what is the decimation factor by a factor 3 and the interpolation by a factor of 3. So slowly we will extend the first signal x of 3, decimation by a factor of 3. So we know the expression for the decimation y of n is equal to x of dn. Here d represents their what term, the decimation or the downsampling rate. So rate is here is 3. So by seeing the given input signal x of n, we can infer that every third samples are to be considered. The remaining signals will be totally removed from the given x of n, and that is what happened here. Okay. Now we'll go for the interpolation. So interpolation y of n is given by x of n by I. In other words, we can say which is equal to x of n by, where I is given here as 3. So the output signal is shown in the figure, and which could easily obtained by inserting 2 rows between the 2 successive samples. The reason of inserting two zeros because between 0, then we have 1 and then 2, and then we have a third sample. So that 2 samples has to be made as 0, and then we'll go for third sample. Similarly 4 and 5 will be 0, and then followed by the third sample will be 6, and this goes continuous. So with respect to the unit step sequence x of n only, I have been plotted what is the decimation factor, decimated signal x of n, as well as the interpolation with the factor of 3. Now let us move further to another problem of it. Consider a ramp sequence and sketch its interpolated and decimated version by a factor of 3. And here also they have given the input signal must be scattered or must be rated with a factor of 3. But the given signal x of n here is nothing but what? The ramp step sequence. So the ramp sequence is denoted here as r of n, and it is given by n into u of n. That is, if x of n is equal to 1, your y of n also will be equal to 1. If x of n is equal to 6, x of y of 1 also, y of n also will be equal to 6. So there will be an equipotential elements will be keep on moving between this x of n and y of n for the sake of generating a ramp sequence. So it is very clearly given that the given signal r of n or this x of n is nothing but by a factor of d. For the case of a decimation, it has to be downsampled, and for the interpolation, it is it is upsampled by a factor of n by I. So there is only changes which takes place in the case of the given input signal RAM. So now we'll consider the factor of decimation. So y of n will be naturally equal to 3 times x of n, that is into x of 3n. So every signals will be sampled at regular intervals of 3, and the remaining in between samples which are there will be totally removed from the analysis. Similarly, when we plot the factors interpolation factor 3 between 0, 3, 6 and 9, the signals will be interpolated or will be transmitted, whereas the subsequent signals before the third samples, we have sample number 2 and sample number 1, and they will be made as logic 0, and this similar fashion will continues for a regular time intervals of t is equal to 3. So this is inferred in the PPT as a pictorial representation for both decimation as well as interpolation. The first question with the signal unit step, it doesn't require any knowledge of the given input signal x of n, just we have been plotting how the signal x of n directly appeared. Whereas the second set of example denotes that it is a ramp type or ramp version of the input signal. So based on the ramp signal, how does the signal responded to both decimation factor and interpolation factor? There is nothing but the key challenge, and we have come across with a problem. Thank you.